So I'm going to count and insert.
Wait, you tell me when to start the timer.
Your timer is on, eh?
You first take out my phone.
Okay. I'm going to count
Wait.
down. 3,
2, 1.
So,
3, 2, 1.
Send me that picture.
No problem. So the voltage is rising. Looks like we may reach 10.
you have 10 seconds.
You want it? That's his name.
Okay.
Wow. 70.5. Wait. Who saw the voltage?
The voltage is the scale. That's where the video comes in. The voltage for computing.
So how come it's still in?
We are continuing. It's a continuous process.
So
At
now
60, you will not.
I set my time to 60.
You should have set a count up timer.
To 2400.
Like it goes up.
Yes.
No, it just goes up. When you see 30, you record. When you see 60, you record. When you see
And it's like
120, you record. When you see 150, you record.
Let me see how many minutes. Because my time only stops at 60 seconds.
Really?
How old is the time?
No, count up.
It does debate things.
You do count up timer. Count up. It's a timer. It's a count up.
But you have a
Count.
stopwatch as well.
Yeah, stopwatch. Yeah, that's the word. Okay.
So I
This
put
one can do as like
240 seconds. But
take a 1 of 0.
Now, do you see that the video is a better choice? I'm just praying it doesn't reach past 8 volts.
And no, I'm getting worried because your thing is still on. This has reduced to 10. It's variable, and we're not recording 10. So how?
Now that one is measuring current. This one is measuring current.
And
No.
isn't it getting drained?
We are supposed to note the voltage and current at time 30, at time 60, at times
Hey, at time is 0.
like time is increasing.
So let me see.
This 17.5 was what time?
I just start the stopwatch like that.
Yes. So you, when
I
it
start?
and now it is now past. We'll just rely on the video.
Yeah,
Because
once all
this
that
was
info
to
system-
help us have a check for the video.
I want to hold that phone like that for 48
For 40
minutes.
minutes.
Yeah.
As we're doing literally nothing. I saw something like recording squares.
We'll see it from the video.
So the entire experiment for today, what you have to do is about this.
No, we also
Relying-
have AC.
Come to think of it, even the voltage is shown there for channel 1.
7.76.
So we may not even need to use the other bar.
What's the name of that thing that came into you now?
I don't know.
Yes, you have muscles.
So literally 40 minutes.
And then the AC part. The guys warned us that it is a test of resilience. The AC part required us to also use one capacitor.
Check.
2.4. General the sinusoidal waveform of 10 volts, peak to peak, whose period, those milliseconds, and S. He wants to type. Oh, subject. I was like, what's the word? Subject. I was trying to see, and S, object. So I'm like, subjected to a series capacitor circuit with a capacitor and a resistor, respectively. And we have this resistor. So this capacitor. 2.5. Do we have it? Oh, he said we use 200 in series.
Cannot give it
100?
47 to 47 can give you 2.5.
Very put them in series. Hey, check our connections. At 6 minutes, I'm already exhausted.
You can check it.
I know it's okay. Let me try to push it to 20. Has that become constant? You say 200, 2400 seconds becomes how many minutes?
40.
Yes, Christo.
Where is that? Calculated. This one is 40. 60. Which is 24. My math is improved, but I haven't.
So that's 240 divided by 6.
Then it's 60.
Yeah, it's 40. I hope I have enough storage. What if it wasn't supposed to have a zero? Because the values are more stagnant.
Now our current is constant.
More or less.
But everything is constant.
The voltage is
It's changing.
fluctuating slightly. I hope the scale.
For how long have you been there? What are minutes?
I leave it. Will I see the
That is a good
multimeter? I think at this point it's almost going to be a straight line.
So then we should see. Because the values are almost constant now.
Yeah, you'll be looking for someone with the one that can measure capacitor. Delta.
In the meantime, see if you can see what you can do. What's you don't have. No, Jazz. You take your phone.
You never see the PDF?
Turn it up. Kinako PDF. Hey man, this girl. Anyway.
How could you be setting up that thing to supply us the AC voltage? Sinusoidal? Because I mean, I see this is stationary.
That's a question.
Yes.
Is it a mission? Teacher, we are using. Teacher, come mango. Mango.
Your phone was there. You
No,
left
it's
it.
on battery.
Yeah, so please don't stress me.
That's why I'm getting my report. You know, it is. And you must use this.
You just positivity and gratitude.
All of this is covered. Actually, from where I was covered, it was
Because the big experiment.
Which one? Let me check this. Which one?
Current,
Tiny. It's what we are recording here.
square numbers is said out in the video. Yeah, there's a point it will be constant because the curve will be like this, then
Even
After
our
20
values
minutes,
have
I'll
become
stop recording.
constant.
yes, relax, it's just this. And then the AC.
What is the time?
Oh, it will in the video.
So you are currently on 13 minutes.
Mm.
And the current is not changing.
Yeah, it's constant. It has been constant since 7 minutes.
Since 7 minutes.
Mm.
That's been a long time.
No, it has been constant since 7
From
minutes.
7 minutes to 30, 30 to 40 is basically.
It's constant. I'm going to stop this video at 20 minutes. Then we'll go for
AC.
AC.
The other side, the one of 10 volts peak to peak.
I'd already created the 10.
What? Put it again.
You've taken it to root mean square. We want peak to peak.
Peak.
There, it's already at 10.
Which period is it? Which period?
But I think we stop from there.
20 milliseconds.
Yeah, I'm also
Don't
going to
stop
stop.
at
I'm going to stop it at 15. Okay, at 20. As I see now, it has gone to 2. 8.2.
We can stop from there and then we guess.
The way you want to check my cables. You why is our multimeter?
Now, I want to take this one, then I bring another one. Yeah.
Oh, okay,
For
let
the
me stop.
capacity.
On that ground, let me stop. I'm going to stop.
Physics, we cannot pay for 40 minutes.